All right, we are tackling some information or a section that is not in your textbook, and so we're going to rely completely on your packet materials and your notes. Okay, so turn to 9.4b where it says surface area of cylinder. Our essential question will be, how do I find, or in other words, calculate the surface area of a cylinder? So we have to get a bunch of terminology and vocabulary here under our belt. So let's talk about a cylinder. A cylinder, I often like to think of something like a Pringles can, a soup can of tuna. Even when I'm looking around my classroom and I see my container that has my disinfecting wipes, they come in like a cylinder shaped thing. So here's what we're after. A cylinder is basically a prism, which means, in a sense, and I should say it's prism-like, meaning it has a top and a bottom base. Okay, so it has a top and a bottom base that are exactly the same size. And then you have a certain three-dimensional component to it because you have a height. So you have base, and then it just comes straight on up. So it's top and bottom base. It happens to be circles, those bases. It's three-dimensional. There we go. Okay, so I always think like a can of something. Okay, soda can, soup can of tuna fish, Pringles, whatever. Okay. The base, that means it is the shape that is the top and the bottom. In this case, there are two of them, and they are exactly the same size, okay? And they happen to be circles. And if you want, on your diagram, you can kind of shade in with some lines. There's the top base, the bottom base. They're exactly the same size because zoop, it just goes straight up. The height measures, or it's a measurement that determines how tall something is. So put the letter H over here. I guess I made that a capital now. Oftentimes we just use little h, but here we go. Height. Okay, that's how tall the cylinder is. Okay, those of you that play football, as we're looking at this, a lateral pass, or if you have, when we talk about quadrilateral in math, the word lateral has to do with sides. So when I say the lateral surface, I'm talking about the sides. Or in this case, I'm going to put that S in parentheses because really it seems kind of strange to talk about the side or the lateral side of a cylinder because it's all curved. Okay, I don't have rectangles here. It's just one side in a sense. And we're going to see what this looks like when we unfold it. Okay, if you can get and envision, if I could somehow take a scissors or a knife of some sort and cut open that Pringles can, or even think about taking the label off of a can of soup. Okay, what this looks like when you unfurl it or lay it out flat two-dimensionally is you are going to have a circle, and then you end up having this label, that side, that's a rectangle because that wraps around, and then you have the other bottom base, that's a circular shape on the other end. So you have a top, a bottom, and the sides. All right, so we often call it the two bases, top and bottom, and then one lateral face or a lateral surface, which is the side. So when I talk about surface area of a cylinder, I just mean it is the grand total of all areas. And here's what it's going to look like. And it gets kind of cumbersome because I like to write it this way: circle plus circle plus that lateral side, which is the rectangle. Okay? Top, bottom, and the side. Top, bottom, and the side. When we talk about a formula, I'm going to right now leave this kind of in rough form with a picture because I really want you to think about it and not rely on memorizing some kind of formula. So I want you to say circle plus another circle. So this is the top and this is the bottom. These are your two bases. And then we have the side. Now leave some room under here because we need to add some information here specifically about, all right, how do I find all of these parts? This is a circle. I want to find the area of the circle. So you know that means we take pi times radius, or pi r. I'm going to start writing this as pi r squared. Same thing here. Here's another pi radius times radius. And remember, we need the radius, okay, as we calculate. So I have circle, circle. Now I have the rectangle. A rectangle, you know, if I can find the length times the width or this base times its height, well, then we're good to go because that's how you find the area of a rectangle. I need you to envision where this rectangle came from here, okay? Here, here. This side here is the height of the rectangle, or the height of the cylinder, I should say. All right? So that gives you the H. I'm going to put a letter H here next to this rectangle. Now we got to talk about what's the length. What's this? This is the edge that wraps around the cylinder. This is the label of the soup can. This is where it says Pringles and has pictures of that. It goes all the way around, all the way around, all the way around. We're just flattening it out straight. What is all the way around this circle? We just talked about that in the first section. All the way around the circle is the circumference. That's the distance around that circular shape. So really, this rectangle is circumference times height. All right, smarty pants, do you remember how to find circumference? Way back there in section number 1, you got this formula back here that says circumference is pi times diameter. So instead of writing C here, I'm going to say inside my rectangle, pi times diameter, that's basically the length of this rectangle, and this is the height. So this is pi times diameter times height. Now notice I like to write it as radius squared here, and I use diameter here, and I simply need you to just be able to discern between the two. Now, tomorrow we're going to get into more examples. I'm going to stop here, check Schoology for what your assignment is so far, and we'll go from there. Good luck, and may the force be with you.